classes on organic chemistry, and today's class is aldehyde and ketone, and it is the last class on the practice set 11, and it is the continuation of practice 10. And here today's class I have subdivided the class into 4 sections. Section 1 is reaction with, that is reaction of aldehyde and ketones with Grignard reagent and reactivity of aldehyde and ketones, and third one is the 5 name reaction, and fourth one is the nucleophilic addition cum elimination. So this class is very much important. Please minutely follow the class. Here, first of all, as per my schematic representation, I will start with the reaction of aldehyde and ketone with Grignard reagent. So before this one, many of you have got in elaborate in my class of aldehyde and ketone. Please subscribe the class. You will get all details on the chapters in descriptive manner, and today I am going to solve the questions answer of different entrance exam and practice sets. And hence, before starting this one, let me first tell me the mechanism. First you know the mechanism so that you can give the answer, otherwise you can't answer the questions. Say you are asked to react with this. This is ketone and this is Grignard reagent, CH3MgBr. And in Grignard reagent, very often I told you C is negative and Mg is positive. MgX is not at all reactive, but its presence or attachment with C, this that is non-metallic carbon, due to electronegativity difference, carbon gets the charge negative, and due to this negative charge the reactivity occurs. It becomes too much unstable and act as an anion, and this anion reacts with this one. Here what's happened, due to a resonance or electromagnetic effect, you see this bond is withdrawn in this way, and this becomes partially positive and this becomes partially negative. So this is electrophile, electron deficient center, and this is an anion due to the presence of MgBr and C bond of non-metal, and the nucleophile attacks the electron deficient center this. Thereby the pi bond electron kickbacks to O. So you get, first of all you write the technique, you see the technique, you write the ketone in this way. Bond is withdrawn, kick back to O, most electronegative O, that O earlier it has 2 dot, and due to withdrawal it has got another O, and when nucleophile attacks it get attached. So this attached with this. Am I right? Next step is acid hydrolysis. So there you get this. So this bond is withdrawn towards this negative charge, withdrawn towards proton. Thereby you get CH3COH, CH3CH3. So very often in CO group, along with O there is H, it becomes alcohol, 3-degree alcohol. And you please keep this mechanism in your mind, because sometimes the product is given and one Grignard reagent is given, you will be missed out this one to find out. So mind that whenever this product is given, you find C is attached with OH, means there is CO, and above all this CO you are getting one R group, and that R group has come from this. So sometimes Grignard reaction is termed as carbon extending, where the chain of carbon is extended or number of carbon is extended, initially 1 to 3 carbon, and along with this you are getting 4 carbon. So please keep it in your mind to answer the different type of question. Let us start with the first question, which was asked in Roorkee, BHU, RPMT and MHCAT. Grignard reagent reacts with acetone. I've already shown the answer. A lot of options are given. I will not show you. You assume any Grignard reagent. Say this is CH3MgI or Br, anything, plus acetone. The acetone is CH3, C double bond O, CH3. The answer is very simple. What is the trick? I have shown you the mechanism. Trick is you just write the aldehyde or acetone, CH3C, and in place of O you just add this one. You keep this CH3, and whatever alkyl part is here, you please attach it with this one. This is the answer. In the option, a lot of alcohols are given, but 3-degree alcohol is the correct answer. So the first question is over. Second one, benzaldehyde reacts with Grignard reagent. Again, your Grignard reagent is CH3 MgBr and benzaldehyde is this is benzaldehyde. So a bit earlier I told you that the reaction is concentrated on carbonyl carbon. It is electrophile. Due to resonance C becomes, so your answer will be this part remains same, and here in carbon you just give single bond O and here H, and H is in its position, and that R part will get attached to this. This is always apply the technique to get the answer. Next one, aldehyde to Grignard reagent gives you P, on acid hydrolysis gives you B. The question was asked PB, CET and RPMT, and you are asked what is B. So again, your Grignard reagent is CH3MgBr and aldehyde is like this. So the same way, this is negative and this is positive, am I right? So what the technique is, you keep it as it is, give it single bond, along with this you give H, keep it as it is, and this R part will get attached here. Very simple, just follow the technique, you will get the answer. I have shown you the mechanism, minutely follow the mechanism, you will get the answer. This is in simple the reaction with aldehyde and ketone with Grignard reagent. Now next part is reactivity. It is very important, and to arrange in increasing decreasing order of aldehyde and acetone towards N reagent HCN, nucleophilic addition or anything, you first know what are the things which affect the reactivity of aldehyde and ketones. There are two things. One is I effect, inductive effect, plus I and minus I. We will concerned with plus I effect, and other one is bulkiness. So in short, plus I effect, in short, the reactivity is inversely proportional to plus I effect, and here again reactivity is inversely proportional to bulkiness. A bit later I will explain what is bulkiness. Now first of all, plus I effect means alkyl group CH3, C2H5, C3H7, etc. more the number of CH3 group. Let me explain. Say it is aldehyde. So we see it gets slightly negative charge and it is slightly positive charge. So we get there is electron deficient center in C. So if you want to make reaction with nucleophile, so what's happened? Nucleophile will prefer to attack in the electron deficient center carbon. So this positive center, if the positivity on that carbonyl carbon is more, so the reactivity of nucleophile will be more. And if the positivity in some sense is less, for some reason less, then reactivity will be less. So say CH3 group is plus I group, it pumps electron and it withdraws electron. It becomes positive due to withdrawal of O. More electronegativity, a bond is withdrawn here and it become positive. And due to the pumping nature of CH3 group, this positivity on carbonyl carbon decreases. Hence, reactivity will decrease. So, if you again add one CH3 here, so in this case, you will get more plus I effect is there. So, less is the positivity on carbon, which is caused due to withdrawal of this pi electron towards oxygen. Am I right? So more the plus I effect, less is the reactivity. Number 2, if in alkyl halide, aldehyde or ketone, if there is CH3 group in place of a CH3, if it is H in one place, and say if it is this, if it is CH3COH, if it is CH3COOCH3, so in one term the electronegativity on carbon is decreasing due to plus I effect, so reactivity will decrease. Now if in this position, if I add C2H5 or if I replace C3H7 or if I replace pH means phenyl group, again if I replace by pH group, means if the alkyl group on either side of the carbonyl carbon is either C2H5 or more number of CH3 or more the number of C2H5 or more the number of pH group, means bulkiness, means the bulkiness surrounding CO group will increase, and due to this bulkiness reactivity will decrease. There are two factors will come into play. Now what's happened, we will explain each one upon these two fact. Now question, you are asked ethanol, propanol, propanone, butanone. You are asked to arrange, Allegro Muslim University medical entrance, arrange in increasing or decreasing, whatever way you are asked. This is HCHO, ethanol, CH3CHO, propanol, CH3CH2CHO, propanone, butanone. What you see here, there is CH3 group, there is C2H5, again there is propanone, again there is butanone. Whenever you process from left to right, the number of alkyl group, and here CH3 group, alkyl group is increasing. The more the number of alkyl, more is the number of chain of the alkyl group is more, plus I effect is more. So at the very beginning I told you, more the plus I effect, less is the reactivity. So this will be highly ethanol will be highly reactive, then butanol will be the butanone will be the least. Am I right? You arrange in this way. Next one, again you are asked HCHO, CH3CHO, CH3CO, CH3, C2H5, CO, CH3, C2H5, CO, C2H5. You are asked to arrange increasing or decreasing order of reactivity. Again you see, as you passes from left to right, you see this is CH3. Here in place of CH3, this is H. This is CH3 plus I effect is coming into play, or This is CH3 on the both side of C, means bulking is increasing. Again here CH3 is around CO, C2H5, CH3, around CO, C2H5, CH3. By due degrees, as we pass from left to right, we see the bulkiness around CO is increasing. So, since the bulkiness is increasing, so reactivity will decrease. It will be the least and it will be the highly reactive. This is the way you will arrange in increasing or decreasing order. Next, increasing order of the rate of addition of HCN towards same HCN means here cyanide. Cn negative means nucleophile will get attached with the carbonyl C, and that again depends upon bulkiness. You see here CO group is surrounded by H only. Here CO group is surrounded by CH3. Here CO group is surrounded by PHCH3. Here it is surrounded by PHCO-PH3. So more bulkiness is here. It is least reactive and it is highly reactive. It is second. It is third. Am I right? Very simple. Just you follow the technique. The two factor I have mentioned. Basing upon this factor, you explain. This reaction was asked in IIT screening. Question was asked in this one, and that question was asked in AIEEE. The third part of today's class is again the name reaction, 5 name reaction, and it is very important. What are the typical question asked from the 5 name reaction? One reaction is the Clemenson reduction. Second one is Wolff-Kishner reaction. Third one is Rusenman reaction. Fourth one is Ald reaction. Fifth one is Stephen reaction. So these name reactions are very important, and along with this name of this reaction, you must know what are the reagent. In Clemenson, mind that all these reactions except Ald and Stephen, this is the reaction which you will find in the preparation. I have already mentioned in the first set of the solution of entrance exam, but set 1, and Rusenman is again preparation of aldehyde, and here Clemenson is the reaction where ketone groups converts to CH2. Wolff-Kishner again where CO is converted to CH2, and Rusenman CO acid chloride is converted to CO. Ald toluene is converted to benzaldehyde. Stephen cyanide is converted to CHO. This conversion you know as a cheat sheet, means shortcut, the normal notes or noting before solving this one. So Clemenson reaction, we know CO is converted to CH2, but a complicated structure will given. You will search where there is CO group. Wherever you get CO, you just convert into CH2. But the reagent here is zinc, mercury, and HCl. This is very important. Wolff-Kishner, again CO is converted to CH2, but this is a very important, very typical question or very often asked. Here the reagent is NH2 and a base, sodium hydroxide, potassium hydroxide, base OH. But the matter is same, CO is converted to CH2. And in Rusenman, here we get preparation of aldehyde. Acid chloride is where CO is converted to CHO. Am I right? CO is converted to CHO means in place of Cl, we just add H. What reagent here used is hydrogen over palladium sulfate. Very important. Minutely follow this thing. I will ask you the question I have here written already. And here, this is toluene. Toluene has converted to benzaldehyde, CrO2Cl2 chromal chloride. The reagent is very important. You should know this one. And there is one intermediate product is formed before getting to final one. Sometimes in 2 years ago, in NEET, the reagent intermediate was asked. And Stephen reaction, you will get stannous chloride and HCl, then CN, and I am not talking about this part, maybe double bonded part, maybe simple alkyl part is there. So these are the reagent. Very often you will get confused to give the correct answer. So let us take one example out of this. Here CO converts to CH2. The question is DCECET RPMT PBCAT asks what reagent is asked. If nothing is given, you can either use zinc mercury HCl or hydrazine OH. You are okay. Both the reagent can convert this one. Whatever the reagent is given in the option, you choose out this or this. Anyone will be given. So first one is over. Now what is second one? CO on reagent A gives you CH3. But in the exam, it is given here A is Zn, Hg and HCl, and you are asked what is the name of the reaction. So CO converted to CH2 and reagent A is here is zinc, mercury and HCl, and the reaction is nothing but Clemenson reduction or Clemenson reaction. So the name of the reaction is Clemenson reaction. Second reaction is COCl is converted to CHO, and you are asked what is the reagent used. COCl is converted to CO in place of Cl there H occurs. Am I right? I told you it is Russellman reaction. It is from preparation, and you are asked what reagent is used to convert this to this. Answer this to this H2 palladium over barium sulfate. And you are also asked what is the name of the reaction. Answer is Russellman reaction. Third one is in question it is asked CN group on treating with HCl and SnCl2, it gives CHO. CN becomes CHO. The reaction name of the reaction is Stephen's reaction, and we have already mentioned here. And third one is asked in AIEEE, last one. It is very important, you must know, otherwise see, you just minutely follow this question. It is asked in AIEEE because question is a bit tricky but not hard. How to solve out this one? So as earlier I have told you, if CO group becomes CH2, so the reagent is either Clemenson reduction reactions, or it may Wolff-Kishner NH2NH2. Am I right? Zinc mercury NaCl or NH2NH2 oblique OH negative. But here A, according to my explanation, either Clemenson reagent or Wolff-Kishner reagent. Wolff-Kishner is the reagent. But here it is not correct. You see, yes, it is the same that CO has become CH2. So either Clemenson or Wolff-Kishner, both the reagent is valid. But here we will choose NH2NH2OH because zinc mercury and HCl for Clemenson, and this is Wolff. Am I right? Clemenson, this reagent is not used to convert this to this because here there is acid, and in presence of acid, carbonyl group and OH are very sensitive. They will simultaneously even double bonded compound will be affected. So if double bond CO is very sensitive towards acid, so if you use this one, you will not get this one. Here we see double bond and OH remain intact, means we should use this base where NH2OH does not have any effect on double bond and OH. So instead of Clemenson reagent zinc mercury HCl, we will use NH2OH. In exam, both these options are present, hence minorly tick this answer, otherwise your answer will be wrong. Now, the last part of today's class is nucleophilic addition, calm elimination. There are two types of reaction. Again, we can see in aldehyde and ketone. One is nucleophilic addition. Let me see one example and with slight mechanism so that your backbone will be strong. Say CH3, C double O CH3. If there is nucleophile is Cn. So earlier I have told you, and this pi electrons, when it attacks the electron deficient center, here the pi electron is kicked back to oxygen. So what we get here is CH3, CO and Cn, this. And here if you use H, there is H positive, then next step there is protonation, that bond is withdrawn, and in next step you will get CH3O HCH3Cl. Am I right? So this is in short the mechanism where we see nucleophile get attached. So no doubt nucleophile get attached and added, it gives addition. So this is nucleophilic addition. Sometimes you are asked what type of the reaction it is. I have written the reaction question, you will get it follow. Now what is nucleophilic addition calm elimination? Here, before starting solving out this question, I am showing you, this is ammonia. When one hydrogen ammonia is replaced by some different group, you will get one time it is OH, another time it is OH, another time. In short, I am showing you a lot of reagents are there, and I told you this is Brady's reagent, or this hydrogen, another hydrogen of ammonia is replaced by this. In short, we write is NH2Z. Am I right? And Z is replaced by OH, Z is replaced by NH2, Z is replaced by whole this group, Brady's reagent, 1,4-dinitrophenyl hydrazine. Am I right? This is one of the very important reagent. Now what's happened when aldehyde, say, or ketone, aldehyde or any ketone, say you write the aldehyde and ketone in this way. I am not showing you the mechanism, and say this is hydrogen. Let us take hydrogen. You write hydrogen is like this. Am I right? And just you do this, but mechanism is a bit different. So nucleophile attack and water released. So as a whole, you will get the answer as this. So along with this, you are getting water and there is nucleophilic attack. Am I right? This whole mechanism I have not shown you. I have shown you that elimination of water. So this is called nucleophilic addition calm elimination. First one is nucleophilic addition only, and there is nucleophilic addition class when the NH2Z is there, means ammonia derivative is there. Always you arrange in this way. The rearrange is arranged in such a way, C double bond O, and rearrange there is always NH2, H2 is back to get O. This is the technique. So let us start solving out the questions answer of entrance for your practice. So first one is you are given RCO, HCN, KCN, and in the first row it gives A, and on the reagent B it gives this. It is a bit tricky, not tough. So you see RC double bond O hardest plus HCN KCN means in you are getting cyanide nucleophile, am I right? That nucleophile attacks and pi electron gets backed on oxygen. So and later on this proton is get attached to this one. In one shot we get the proton get attached and this CN is here and this remain in its place. So this is your A, am I right? This is your A. Minutely follow, but here you were asked a bit advanced. Last year, previous of last year, the question in asked in NEET. This step I will tell you that one. So this is in CBSE PMT. You are asked to give a reagent to get here CH2NH2. If this is OH, you are asked to get this one RCOH CN hardest. So here you are given CH2NH2. So mind that when cyanide group on reduction chain is increased, CH2NH2 comes. It is shortcut, we know it, you must know this. So you use a reducing agent and in your exam option lithium aluminum hydride along with a lots of oxidizing agent were there. So you apply lithium aluminum hydride so that CN of this will convert it into 1 carbon more CH2NH2. Mind to follow this one. But the same question you are asked, you are to get this one from A. From this A, if you want to get this one, so in place of CN, you are getting COOH. Earlier case CN, you got CH2NH2 on reduction and CN on oxidation on acid hydrolysis, we get COOH. So here you are asked B, am I right? So in place of B, either you give this or you give water plus acid, you will get this one R C hardest OH COOH. So both the question was concerned with the oxidation or reduction of CN group and CN groups on acid hydrolysis COOH. So this is the question answer. Reagent is used to distinguish acetone and acetophenone. This is very important. This is acetophenone and acetone, it is known to you. The famous reaction of acetone is sodium hydrogen carbonate. So if you react with this one, it will respond, but sodium hydrogen carbonate will not react with acetophenone. So the reagent NaHCO3 is used to distinguish between acetophenone and acetone. It is a very important reaction, very often in various entrance exam question is asked. Hydrogen on aldol, aldehyde and ketone gives. So first of all, you should know what is hydrogen. I told you this is hydrogen and this has come from derivative of ammonia, means one hydrogen is replaced by NH2. A bit earlier I told you. So hydrogen on aldehyde and ketone. If it is aldehyde, so this will be this, and if it is ketone, this will be this. So your hydrogen, you just write in this way, and you just eliminate water in, combine these two, and here the same NH2 and NH2, just remove these two, you add up these two, you will get two answer, and two options are given. You just do minutely, you can answer this one. It is very simple. Next question, acetal is obtained. What is acetal? First of all, acetal is OR group is combined, is attached with carbon. That R and that 2R may not be same. That 2R comes from alcohol. I will show you, you can understand. It is asked, acetal is obtained. That type of compound is obtained by reacting in presence of alcohol and dry HCl with, what is the reactant along with which will use an alcohol and dry HCl, will get acetal. Answer, aldehyde. CH3, C double bond OH. Here you give H here. Aldehyde, and 2 molecule of methanol in case of place of dry HCl. In details in my class, you please subscribe, so you'll get the class. I have explained mechanism also. So your answer will be CH3, C or CH3 OR or CH3. H will remain in its place. You are asked, will react with what to get acetal? Answer, aldehyde. Option was aldehyde, ketone, carboxylic acid, and lots of ester. So your answer will be aldehyde. Am I right? So just what is acetal, what is hemiacetal, you must have some knowledge on this, otherwise you will miss the question. Next one, which one of the following reagent with carbonyl compound shows addition cum elimination reaction? A bit earlier I have told you addition cum elimination. This is ammonia derivative, where there is elimination is there soon after the addition, nucleophilic addition. Am I right? So in aldehyde and ketone both show this type of reaction. Here one is PCl5 reagent, other is Brady's reagent, other is HCN, other is all. So no question of PCl5. There is no elimination, there is no addition with aldehyde or ketone. Another is Brady's reagent. Forget about this one for a moment. HCN, where CN get attached. It is simple nucleophilic addition. No elimination occurs. CN is introduced. Then another is all never, and it is simple addition. Option is Brady's reagent. So Brady's reagent, a bit earlier I told you, if it is aldehyde, if it is ketone, both the cases, say I have shown you Brady's reagent is this. (2,4 dinitro DNP). It is also called DNP. 2,4 dinitro. It is colored one. What you get? Elimination occurs. So your answer will be CH3, CH3, C double bond N bond NH. Very simple, nothing tough. This is a nucleophilic, shows addition cum elimination. Answer, Brady's reagent. This is DNP, 2,4-dinitrophenyl hydrogen, and or Brady's reagent. Last but not the least is again important and a bit tough, and I think in 2020 or 21 a question was asked, what's happened? A compound was like this cyanide and Grignard reagent was given. Answer, mind that to cyanide I will give you the cheat sheet on the Grignard reagent. 24 reaction shows, and each and every question from GNU will come from this one. When cyanide is there, Grignard reagent, then mind that it will give you ketone. This is the trick. Am I right? So aldehyde ketone, you have sent 1 degree, 2 degree, 3 degree alcohol, but with CN, it will give you ketone. So this is the hints, and you are given, this question was as UPSEE. The question was this. You are given CH3 MgBr. So a bit mechanism I will solve out this one. Let us write it in this way. And Grignard reagent is CH3 MgBr. This is plus and this is minus, I told you. And this will get attached with this one, and this pi electron will be kicked back on nitrogen. So what we get here is, the trick is the same. What we get here is, here this R group will get attached with this one, nucleophile. Am I right? And MgBr. Now next question, how to get ketone? I told you we will get CO group. Am I right? This is tough. Very often it is not given in your text. It breaks into like this. 2 molecules of water come into play. 1 molecule is water is like this, other is like this. Just you follow the trick, otherwise you can't. Am I right? So what you get here, that in the middle you are get NH2H, means you are getting 1 ammonia, and but we are not concerned with that ammonia, we are concerned with the result. So what we get here is, here CH3 will remain same, but with double bond O, I am sorry, you place water, right? Water in this OH2 and here HOH. So here you are getting MgOH-Br, it is side product, no need, and here you are getting NH3 plus MgOH-Br. These two side product is over. So what remains here is CH3 C double bond O, means you are getting a CO group. So your option is given what? The answer is, if you know the trick where CN is there, CO will come. So whatever the option has CO, that will be your answer. Am I right? So this is all about, and last practice set of aldehyde and ketone. In my next class, I will start with another set number 12 with new chapter. Thanks a lot for watching the class, and once again I request you, those who didn't subscribe the class, to remain updated, please subscribe the class. Thanks a lot.